supplementary material. For some reason, I found it at the supplementary material of chapter 5. Well, I'm gonna post chapter 5 soon. So it says bit clear the memory with a mask byte. That's an example of this instruction. The example is bit clear a particular address, and this is a mask byte. You see, the mask byte is an immediate hexadecimal CE. Okay, let's see how this works. This is the mask. The mask is 11001110. This is the mask byte. This is actually the CE that's given here. All right. Now, what are we going to do with it? Okay. We do something like the inverted mask. It's just a procedure. But so let's invert this mask. So every 1 is going to be 0 and every 0 is going to be 1. So you end up with that. That's the inverted mask. And then before the execution of that instruction, the bit clear instruction execution, you're applying this to a particular address in the memory. So the RAM, the contents of that address is this data. This data here is 10110101. Okay, this is the RAM. This is the data before the execution of this instruction. And then the next line is the data after the execution of this instruction. Okay, so how are we going to utilize the mask byte to process these data contents and ultimately produce this last line here? Okay. Okay. The mask has ones, has 3 ones. There are 3 locations that have ones. Okay. It says okay. And do you see those ones? They designate locations. These locations are going to be cleared. Let's lump sum. I'm going to say it in 1 word, 1.5 words maybe. You see, forget about the inverted mask for now. It's the same thing. I will explain this using the easiest way. Okay. Do you see those ones? Those ones is a mask byte, contents of a mask byte. What's the purpose of these ones? The purpose of these ones is that they designate the locations of whatever needs to be cleared. Okay? Okay. What is it? How is that going to be done? Okay, consider these 3 bits here. They have the same locations like these ones. Okay? So you're going to go ahead and replace all these locations by zeros. They are going to be cleared. All right. You have 1 here. All right. This is the contents of a particular RAM address. 01 here. Okay. What's the purpose of the mask? The purpose of the mask is to tell you that in these locations, make it 0. Clear it. So these have the same locations. This 0, and this 1 have the same location like this 1 and 1. So they are going to be 0. So the ultimate result is that we have cleared the memory locations which were designated by the mask bits, The mask byte actually is composed of some mask bits. So we've cleared the bits in the memory location which correspond to the same location in the mask byte, and they are equal to 1 in the mask byte. So wherever you see 1 in the mask byte, that designates the location in the RAM that needs to be cleared. So you see these 3 bits, these 2 bits, they correspond to 3 and 2 here. You just go ahead and clear them. So you're gonna left with this at the end. I hope this is clear.
Okay. Can you repeat that again, please?
Yeah. All right. This is what we need to change. The RAM data before we execute this instruction. So how are we going to change this byte so as to produce this byte? Prince, right? This is Prince. Yeah. All right. Okay. Look at the locations in this byte that correspond to the locations of ones in the mask byte. You just need to listen to me word by word. Find in this byte, change the bits that have similar locations to the places that have ones in this byte.
Right, right.
So this byte has 3 ones here and 2 ones here. So that means these 5 locations are going to be changed in the memory in that byte. So these are the 5 locations, 0, 1, 0 and 0, 1. These are 5 locations.
Okay, I got it.
What are we going to do to them? We're going to clear them because there is another instruction, B set, memory mask byte. This one is a bit clear. So we're going to clear the bits that have identical locations to the ones in the mask byte. Yes.
Right.
So the presence of 1 in the mask byte, it doesn't mean a value of 1. It means the location. This location needs to be changed in the RAM byte. That's the meaning. Yeah.
And it's always gonna be changed to 0. Like
no, not necessarily. It depends on the instruction. The instruction says bit clear. So clear, you change to 0. If it was set, you would make it 1.
It would be 1. Okay, I got it.
Yeah. If it's set, you make it 1.
All right, thank you.
Let me see if I have something to show you in the context of
Okay. Sports.
I have a good example here for the
okay.
What happened? Yeah. Do you see this?
Yes, the PIC pick.
Here you go. That's an example. Actually, I was planning to give this as an experiment in a couple of semesters ago, but then I changed my mind. Maybe some of you could consider it as a project. Believe me, yes. It's an impedance meter or an ohm meter.
Nice.
You know how that works as an ohm meter?
Uh,
Could you raise
yeah,
your voice, please?
I don't think we see the diagram right now. We just see the lists of figures.
This is the diagram.
Can you expand it?
Do you see where it says max and D to A and A to D and all of that?
No, it doesn't show it.
It doesn't show it?
No, we're just watching. We're seeing the miscellaneous figures folders right now.
Okay. Oh, I see. Let me see how I can grab that one.